right, guys, we're grading. We're grading. Here we go. Color pens. Number 4, the final answer should have been 0. And I think you actually could have, at negative 2/3, you could have eyeballed it. The weird thing is on number 4, wasn't there another point that they marked?
Yeah.
Yeah, they technically marked negative 1. In the answer key, they didn't put it, I think, because our book doesn't technically call an endpoint a critical number, which is probably the best thing to do, is to keep endpoints and critical numbers separate. But for those of you guys that did solve at negative 1, what did you get for your derivative?
0.
Yeah, good.
Undefined.
It's undefined because it's dividing by 0. If you were to actually take this derivative, which they showed, and plug in negative 1,
Yeah.
this square root in the denominator would be 0. So it's actually a vertical tangent line, which is why we could call it a critical number. That's why.
Is the square root of 0 not 0?
Yeah, but in the denominator, you're dividing by 0. Yeah. So good. At negative 1, they should have put that also actually in this one, not because it's an endpoint, but because it is a DNE. So at negative 1, DNE, and at negative 2/3, 0. Number 6. Now they use the definition of the derivative. You guys have a formula for this. Absolute value of x over x. If you come from below, it's positive 1. If you come from above, it's negative 1. Long story short, at 0, it does not exist because of the sharp point. Was number 6 another eyeball one, though?
Yeah.
You could eyeball the sharp point? Okay. Number 10, the critical numbers are, what's the RR for? I don't know. There you go. The critical numbers are 2 and 5. Let me give you a second with the neither and the absolute max and relative max. It's absolute and relative at 5. It's absolute and relative at 5. Number 12, I have to go find him, but he's right here. Number 12, the critical numbers, hopefully you got 3 of them. Would have been 0, negative 2, and positive 2. Sorry, here you go. 0, negative 2, and positive 2. Double check the factoring really quickly and the derivative. The derivative was easy on that one, right?
Yeah.
But then you had to factor it
Plus or
completely.
minus. Yeah.
You could have done plus or minus. Yeah, that's okay. 0 and then plus or minus 2. Nathan, what was your question, Ben?
No, I just did it here.
Oh, okay. Number 36 is our next even, if you guys want to get there. Ooh, it's a trig one. Was it a triggy trig? Was it a tricky trig?
Secant.
Okay.
Secant would be a little bit.
Yeah.
Okay, well hold on. First of all, did you use the derivative rule for secant?
Whoa, we jumped straight to
Secant
36.
tangent.
Well, you left between the...
Well, I think that was the next even, right?
Yeah, well, shoot, it was.
Yeah.
That's all.
Okay, so first of all, taking the derivative of secant being secant tangent, then we had to set it equal to 0, right? 0 or DNE, technically? Okay, so hold on, let's talk about this really quickly. Are there any denominators?
No.
Yes.
Wait,
If
yes,
you
there
look
is.
quickly, no, it's over 1, but who is secant? Who is
1 over cosine.
Exactly, so we could go ahead and take this guy and say, oh, that's the same thing as 1 over cosine times sine over cosine. So you could have made it a lot easier if you don't think about when tangent is 0, when secant is 0, just to say, okay, when is the top equal to 0, when is sine 0, when is the bottom equal to 0, when is cosine 0. Nice thing is, if we have both of these, it's just going to be 0 pi over 2 pi and 2 pi. Sorry, 0 pi over 2 pi, 3 pi over 2, and 2 pi. Oh, wait, but we have a very small interval. So technically we have 0, 90, 180, 270. We could go the other direction, it'd be negative pi over 2. Which of these actually fit in that?
0.
Yeah, negative pi over 6 is negative 30. Well, that's too big. Pi over 3, well, pi over 2, all of those are bigger than pi over 3, so the only one that fits is just 0. So your critical number is 0. Now, hold on. You probably wrote this a little bit different. Your critical number would have been x equals 0. The right endpoint that you would be testing would be x equals pi over 3 and x equals negative pi over 6. How did I tell you guys to test? How high is their y, right? So we would have taken each of those x's, sorry, negative pi over 6, 0. And when you plug in, they ended up, when they plugged in, getting 2 over root 3, 2, and 1. Now, this one's kind of hard if you don't have your calculator. How do you know for sure? They did find it, 1.1547. But couldn't you also think of root 3? Isn't that less than root 4? Which means this has a smaller denominator than root 4. And it has a, smaller denominator, which means a bigger number.
Wouldn't that just be 1?
So this would be 1, so it's something a little bit bigger than 1. So that's how you can approximate if you needed to mental map it. Think of what square root do you know. If the denominator has a bigger square root, it's a smaller number, hence the less than. So you can say, oh, he's a little bit more than 1. Well, he's not a min or a max. Because 1 would be the lowest, 2 would be the highest. So,
Why do we keep on looking at the denominator? I just don't get what we're
oh, you mean like when we set the bottom equal to 0 like that?
Yeah, I thought you just said the whole thing.
Yeah, you do. But remember, critical numbers, can you guys help me out? Critical numbers are defined to be the,
Endpoints and endpoints.
no. Those are the candidates in EVT for the absolute extrema. We're testing endpoints and critical numbers. Then the Forever Card 19 said, oh, then who are critical numbers?
They define where the derivative is equal to
0 or undefined.
Good. The critical numbers are where the function exists, so it has to be in the domain, first of all, where the function exists, and where the derivative equals 0 or undefined.
Wait, did you have to Forever's?
So for the 0, oh no, not yet, sorry. 0 or undefined. And so I said, if you have a fraction, you find the zeros by setting the top equal to 0. Because when you set the whole thing equal to 0 and multiply the denominator, it's gone. It's only the top equal to 0. That's the zeros. Undefined will always come from the denominator.
Okay.
Does that make sense? Yeah. So it's from the definition of critical numbers we're still trying to get down. Austin. Oh, yeah. This pen's just not working. Okay. I think we have 1 or 2 more ones, right?
48, 60.
Okay. Number 48.
Then simplify use. I don't know if you have.
Okay, you had an A through D, and you were dealing with the function the square root of 4 minus x squared. Let me give you a second. When it says minima, that's just a plural of saying minimums. You don't say minimums, you just say minima instead. Instead of saying minimums, you say minima. So there's 2 of them. And then a maximum. B was only a min, C was only a max, and D was only a max. I think there were some holes on that one, right? Were there some holes that kind of messed that up?
Yeah, there are holes.
So be careful. Can a min or a max, if the highest would be at a hole, can I say that there is one? No.
You can get infinitesimally.
You can get infinitesimally close, right? Like point, no. You can never actually be right before the hole. Couple more seconds. Our only other even is, I believe, 62, yeah?
Can you say 0.9 repeating? Or,
But that isn't a definite place. Does that make sense?
oh,
I like the idea. Like, I know what you're trying to say, but no, we can't do that. What's our last one, 62?
Yes.
Okay, and it's something similar. You're identifying points, and I think it was one of those, like, pictures like we kind of had in notes, right? With the points, and you were identifying what it was. So then number 62, there he is. Although he's kind of small, I'll make him a little bit bigger. A is an absolute min, B is a relative max, C is neither. D is a relative min, E is a relative max, F is a relative min, G is neither. So neithers can happen at critical numbers and endpoints.
wait, so.
Yeah, Charlotte.
Can B be the absolute maximum?
Let me see.
Yeah, that's what.
That's what you thought too?
Yeah.
Oh, maybe, were they not having you label absolute?
They were, but it was like the other highest point
Was
was a hole.
Yeah.
Oh.
So this one's like the next highest.
Okay, so let's check it out real
Right or
fast.
wrong?
And then you guys also look over homework. Some of you had questions on odds and evens, so be ready with those ones, but let's look at 62 first. But I know that some of you guys had questions. Okay, B cannot be an absolute max because the graph goes higher.
Okay, so.
And so we say no max because where it would have had a max was a hole. And And I can't go 1 before g because that would be way removed. I can't go 0.1 away, 0.01 away, 0.00000001 away because there's still more in between. So since g as a whole, that looks like it should be the absolute max, I have to say none because this guy, points go higher than.
Okay.
If he was tied, I could put it in.
So-
but-
What's your question, sir?
Yeah. Yeah, what other questions do we have?
Oh,
19.
Oh, Nathan, you have one on 62,
Fine,
sorry.
62. So G obviously is none, but E can be a local max and F
Local.
can be
Local.
local min,
Local.
even though they're sharp points.
Local. Yes, because critical numbers, wait, definition. F prime is 0 or undefined. Yeah, good. Number 19, let's go peek at it. The rest of you guys have questions, have them ready. Any questions before 19? Any questions before 19? Okay. Number 19, kiddos, our objective was to find the critical numbers. The derivative was tricky, and can anyone tell me why it was tricky?
There was a log and a product.
Yeah, there was a product rule times, and there was a log. So, someone walk me through. I'm a little puppet. I'm just doing what you tell me to do.
Well, then you change the base point.
Is there-
You need to outline.
Two x
No, that's what they
times
did in
log.
They did that.
CalcAB, and I was just like, no.
Plus
We
one.
could change, or we could just use our rule. What do you guys think?
So now in CalcAB they change it to outline, right?
Let's go.
Do 2x times that log, and
Let me
then
show you really quickly what they did in CalcChat then. They said, I don't like log base 2, which I guess I don't either. They didn't like log base 2. So you can do the change of base formula, which says just change it all to ln's.
Oh, then
so much longer though.
But then you can make 1 over ln of 2 a constant.
Wait, let me see, where did the x squared go in front of the log?
Can you go?
Oh, this is just me rewriting.
Oh,
So this
okay.
is how they rewrote the logarithm. Is that they used the change of base formula, and the ln of 2 is just a constant, so we could just make it a coefficient.
Oh, so it's just saying from everything from log.
Yeah,
Right? Okay.
yeah. But we can, did anybody just use our rule log base b of
I
u?
didn't
Yeah,
do
let's just do
that
change.
one.
I did.
Yeah, we can just do chain rule. They decided to go to ln, but I say we have a rule for this guy, so why go to ln? Unless you don't remember the rule. If you don't remember the rule, you're in trouble. But don't we have to use product rule before chain rule?
Yes.
X squared times. X squared times. So then we go ahead and go second gets to stay the same, d first plus first. Does anybody, maybe you had to review it last night, remember log base b of u?
1 over u ln b times u prime.
Good. 1 over u ln of b times
U prime.
u. Now, that is another way, because this was their way of dealing, and then you would have had to plug this in for log base 2 and do the derivative. The other way was to use the formula d dx of log base b of u is 1 over u like ln, but you need an ln of b, and then your u prime. So this is the rule that we used when we had log base 2 of u.
And you can pull out a 2x, but
Yeah, you can pull out a 2x, but there's not really tons more you could do. If we did a common denominator, I'm not sure they simplified it a lot. Did they simplify it a lot?
That's great, Sean. So let's, yeah.
I mean, I guess at this point, if they did simplify more and you were trying to make match, and some like ln thing happened, then they might have changed this one at this point, because if you guys look at it, don't both of them technically have an ln of 2 that you could also pull out? So they, either you change the base first before you derive, or you change the base second. I mean, you can pull out a 1 over ln of 2, that's true. But I really don't think there's too much more that they should have simplified. It's just not gonna get much prettier past that. So, yeah, sorry about the ln's. They do sometimes like to change the logs to ln's.
Still, like,
The only way I knew how to do it was from the CalcAB way.
Yeah.
It was kind of easy.
Yeah. So they use change of base. They use change of base. Any other questions on homework?
you're not supposed to simplify it, you're supposed to find the critical numbers.
Oh, Oh, sorry, I forgot. I was just finding derivative. Critical numbers. Well, one's obvious.
Yeah.
Set this guy equal to 0, each factor. So this guy equal to 0 will happen when x is 0. So we have x equals 0. Struggle is, how do we,
No, I just said that was.
Well-
okay.
we have a denominator.
Is it nothing?
It's awful.
Yeah, if you set that equal to 0, that's going to be square root of a -1. That's imaginary. So that denominator is not getting me anything. So then I could look at my numerator. I could, if I wanted to, I could multiply this guy to get a common denominator. And then put all that together, so numerator set equal to 1. Long story short, this is always positive, because it can never be a negative with a squared and a +1. That's always positive. This is always positive. ln of x squared plus 1, you could kind of check him out too. Long story short, I have never seen anything this complicated on a non-calculator question. So if you were allowed to use your calculator, you could have graphed the original and looked for like places where it levels off and try to find maximums and minimums that way. Or you could just graph this whole guy, just the numerator, graph him and see if he has any zeros. The whole point, if you have your calculator, is that you can use it to find things like zeros in what menu? Second trace. And you could actually, if there is a 0, find it, and it would be a nasty decimal, and that's totally okay. So you wouldn't be expected to solve something like this by hand. You could plug in x squared plus 1 times ln of x squared plus 1 plus x squared. And when you use your grapher, you're looking for zeros. That'd be a way to use your graphing calculator to find what you need to. So good question on that, but I think the only one ends up being 0. Can anybody check
Yeah,
that?
it's only 0.
But you shouldn't just ignore the other part, but if you
Like
graph
that.
him, he has no zeros. He has no zeros, so it's okay.
So for,
Yeah.
absolute, or for maximum and minimums, so for number 51,
Okay.
it says use your graphing calculator to find all of them, and obviously you can graph it and that's all great, but do you use second trace max and min to find what you need?
Yes, if it says critical numbers, absolute extrema. Yes, use second trace, but if an endpoint is higher or lower than a max or a min, don't you need to also use value?
Oh,
So not just the max and min, but you might also have to actually plug in the endpoint and say, wait, the endpoint goes higher, so don't use the max or min, you're gonna have to use plugging in the endpoint to find the y. Does that make sense? Okay. I mean, we'll work more with our graphing calculators throughout as far as how to use them when we get to use them. How to use them when we get to use them. Any other questions though, guys? Okay, we're okay? Okay, let's get to our multiple choice. We're not going to spend tons of time on our multiple choice. But let's see how far you guys were able to get in your workspace.
Oh, I get you.
Actually, let me do this. This will probably be a little easier for us to see. There we go. Okay, what'd you guys do for 74? Find the true. Now careful, sometimes they say find the false. You have to be really careful, but find the true. What do we have? A min at -1, -5?
No, it's a whole.
It's a whole, no.
Yeah,
Okay.
you're right.
An absolute min at 4, 0,
No, there's
Go
no
slower.
points.
has a max at 2, 4?
Why, yes, it does.
No. A good AP question would have marked 2, 4 and labeled it for you, but yes. No extrema? Well, no, there's a max. Is that okay?
Yeah.
Good. We like that one. 75. Woo! Did you guys go take in a derivative for me?
Yeah,
you
know
Okay.
us.
You know.
Read off the first step of your derivative, just real fast.
Second.
Read it off, read it off.
Oh.
3x
minus 1 cubed times 2x
Plus x squared times 3
squared
with 3x minus 1 squared times 3.
3x minus 1 squared times 3.
Okay. Bring down the 3, make it a 2 times. Does that make sense? Now, pause. This is disgusting to set equal to 0, unless you look to factor. Now, pause. Why am I telling you to look at these two pieces as to what they have in common? There's a plus in between, right? So what's in common between those two pieces?
Not
a 2x.
3x, an x.
Not a 3x.
Next.
Oh, there is a 3x minus 1. How many of them?
2.
2 of them, right?
Does it also have
There's also an x.
two?
No, not a 2x. There's no 2.
Miss D, did you not bring down the 3?
Oh, yeah. Bring down the 3 for the power rule. I think that's what you forgot. Bring down the 3, make it a 2, and then times u prime. Derivative of 3x
Yeah,
minus
but
1.
where is it on the second step?
Oh, I'm not deriving. I'm pulling out what's in common now.
Oh, okay.
So this one has 3, this one has 2, so I'm pulling out 3x minus 1 squared. That's what's in common. And I'm pulling out an x. So this one has 1 left and a 2 left. This one has 3 times 3 is 9 and 1 x left, but all of those guys are gone. Does that make sense? Okay, that's key. If you don't do that, and if you start actually foiling it out, you're going to have to factor a cubic polynomial at the end. Oh,
I believe.
factor. I believe that?
And what?
Exactly. Pull out what you can. So then we end up with 3x minus 1 squared times x times 6x plus 9x is 15x minus 2. Wow, I did not have to FOIL out anything. And now I see set everybody equal to 0.
It's very convenient.
Oh, very convenient.
1/3, 0, 1, 2,
And there's no like intervals that make
No,
us
no.
discount any? So then final answer would be,
It's very quick one.
it's quick if you see the factoring. Now, pause, I'll tell you right now, on this test when we get there, some people are gonna get stuck on a problem very similar to this because they don't factor out what's in common. Factor out what's in common, it got so much easier that way. Factor out what's in common. Okay, section 3.2.
Did you roll to problem?
Yes, it's true. It's true, it's a life lesson.
What's the life lesson? I missed it.
Life lesson, drop out of calculus and take physics.
No. Life lesson, just don't do it in math class anymore. You enjoy the senior year more.
Shouldn't be allowed to speak in this class. Second.
I didn't say what they said to me.
So that's from you.
This is fast, I keep it. Good conversation.
No, none of this is bad. None of this is bad. Because you understand. I'm
I
joking.
just want that rule.
Guilty conscience.
When
I'm
in
not
doubt,
really going up alone now,
Like,
but
I'm really cold.
I'm really cold actually.
Okay guys, right. Don't have it
Shoot, this
outside.
is recording. Oh man.
Mr. Kim doesn't usually watch our videos.
I don't know, maybe.
tell him to.
I'm not sure if he would care about going back and listening about a polo that was not worn on a certain day.
Obviously, way
you can go
funny out there.
23.
Oh no, I was trying to calm my fears.
You know, can't you go Hawaii tomorrow?
Yeah, isn't that crazy?
Wasn't it say next to Karen?
Next to the theorem, circa 1691, that's just the date. That's just the date, don't stress.
Oh, did Mr. Rolls discover it?
Oh, did you?
You know. You guys remember this, don't you?
Yeah, not particularly.
Not really bad.
I just remember he was
He's
a
interesting.
unique character.
Because there's only 6 of them.
Especially from some sixth
Oh.
grade.
Can we enlarge the first one?
Enlarge the first one? Okay.
Circa
I'm blind, I'm sorry.
It's okay.
1691.
It's frozen.
I know, hold on. I haven't enlarged it yet.
Would you roll the problem with
Hey, a funny sweatshirt idea. Just roll with it. I don't know.
Oh, no.
Hey, that's a good one.
I really don't care, so.
Actually, someone submitted that last year. It didn't win, but it was in the
sorry,
final
sorry.
round.
Was it Kyle?
Kyle Bobby.
I'm doing
No, I love Kyle Bobby.
Oh,
Everybody
just
loves Kyle
Just
Bobby.
roll with it.
Are you gonna say rolling with it?
How
Oh, Bobby.
That font makes me
Kyle.
The kids started calling him Kyle Bobby at the end, like,
I call it saying.
every
Why
day.
didn't we call Cody?
What, it's, oh, it is? Oh.
Cody Bath.
Like I'm
Why?
We called him Cody Bath over there.
You should write it
You,
in.
oh no, you weren't there.
Yeah.
Do you have
You know the person,
You don't need to skip anyways.
He looked,
the person from Pitch Perfect.
Huh?
Like, do that look quick, pitch perfect.
Corey?
He was from like, Texas.
Corey?
No, it was some from India.
Was he staff?
Yeah.
Wasn't Jim, was it?
No. He had like a beard, kind of.
Eric?
I don't even know his name.
Chelsea's husband?
No.
What are we talking about?
Well, anyways,
Okay.
he would call Corey Cody.
Yep, that's true. Austin, how many kids are in BC? 19.
Oh,
I think that's what she
yeah. Including Kyle Pollard.
Yeah.
Kyle Bobby, smart man.
Okay. I'm freezing the screen because I'm going to go get a box. I'm going to go make it yellow.
Oh,
Oh,
I haven't even
Exactly.
written down the
Number
first two you gave to us.
yeah. Yeah, I
Every
think-
night, you gotta do it. Every night, we keeping it tight.
Should I
Like,
actually?
I do it like before I start my math homework. Like it like forces me to like actually
You don't need to have the circa 1691, that's okay.
I turned the
But what the circa 1691 was supposed to tell you that this one comes first. Comes first, yeah, because there are two this section.
Oh, shoot.
There's roles and there's mean value theorem, and as you guys are writing, this one is specific. Roles is specific. Mean value theorem is general. And the specific one was found first, and then it was later able to be generalized. So
Yeah,
technically,
that
the
makes
most
sense.
useful one is mean value theorem in the sense of that's the one that you can use anytime. Mean value theorem can absorb rules, but we still talk about rules since it was original. It was the original, it was the first. Three things have to be true. No holes on the endpoints, aka F has to be continuous on the closed interval. No holes on the endpoints. Look at that smile, she had her coffee today. Oh, this is fun. Extra, extra, if the Dodgers win tonight, tomorrow, Thursday, November 2nd, will be Dodger Denim Day. If the Dodgers win tonight and are the World Series champions, you may wear Dodger hats and clothes. We are allowing denim jeans and pants. So
What a
if,
holiday.
Hey,
They went
shorts?
all out on this.
I think it's Richmond, I don't know. So if the Dodgers win, you may wear Dodger tops and hats and denim for pants. This is only if the Dodgers win.
I don't know my overall.
Obviously, if they lose,
So,
we are
yeah.
wearing regular.
Wait, so if the Astros win, that means I can wear my Astros?
No.
No, they just said if they lose, we have to wear
I'm gonna actually
uniform.
say that. I'm a Yankees fan.
But
But it's still, but whatever.
I'm a Cubs fan, but
what if I'm gonna wear
It's okay to
uniform?
get out of uniform, who cares?
Yeah, but I don't support that.
What if I'm gonna wear my uniform no matter what?
Okay, guys, Dodger.
Man, let's talk about the Dodgers real quick.
Your will be done. Your will be done. Okay.
Let's take out the golf.
The day after Dr. Craven.
Taking off what?
You
Oh,
want
just
to
sketch,
take it
just
out.
sketch.
Close my.
Alright, kiddos, long story short.
Is that like 20?
No, it's not lunch.
This is forever number 21, I think. Wasn't 20 the...
It was.
I don't know, I didn't remember my last one.
This is forever 20.
21.
This is 21. 20 was, I'm sorry if I didn't label it yesterday. Hey guys in the back, I get really distracted with these shush. Okay,
No, it was 19 was the critical numbers.
yeah, but then this one, extreme value theorem, sorry, I never labeled it.
There's 20.
Oh.
Sorry, I put the box and I never actually put 20, I think I said it. I forgot. EBT with the absolute extrema, testing critical numbers and endpoints was 20, so this one's 21.
So it's talking about
Folder coverage.
Okay, so I need you guys to help me visualize, okay? We can't have holes at the endpoints, aka it needs to be continuous on the closed interval, no holes at endpoints. I can't have any sharp points in between, aka it must also be differentiable in between the endpoints. I don't care about at, that's just continuous, no holes at the endpoints. Derivative I need in between, open. Differentiable in the open interval. And f of a equals f of b. If the heights are equal, and I know that there are smooth connections everywhere in between, and I know that the endpoints are included, there will have to be some place where the tangent line is horizontal, where the derivative is 0. There has to be some place, some x in between A to B, such that the tangent line will get horizontal. AKA, if it's going to come up and it has to come back down and it's only a smooth turn, there has to be a smooth turn somewhere. Or if it's going to go down and it's going to need to come back up to this point, there's going to have to be a smooth turn somewhere. And for Tyler's special case from yesterday or the day before, what if it connected in a straight line? Well, then all the derivatives would be 0, not just one, but still at least
Still
one.
lose one.
Still at least one. So this theorem guarantees the existence of a place when the rate or the derivative will be 0. Guarantees at least one. Doesn't tell us where. Doesn't tell us where. In order to find it, we'd have to actually take a derivative and set equal to 0 if they give us that much information. But it does guarantee the existence, if these three conditions are met, that there will be at least one place in between A to B such that the derivative is 0 or such that it goes flat. So, just think, roll flat. Roll flat. If rolls is true, first of all, if you connected 2 points with a secant line, it'd roll flat. And also, if these three conditions are true, if rolls is true, there's going to be somewhere else where you could roll flat on the tangent line. Roll flat. Rolls, continuous on the closed, differentiable on the open, f of a equals f of b, then. Now, that's rolls. That's a specific case. That's the derivative has to equal a 0. Or what must be true to make a derivative equal 0. But mean value theorem, we're going to write this one down today so that we have the bulk of the wording written down today. Then we'll do the bulk of the problems tomorrow. Mean value theorem basically says you can tilt the picture. What? You can tilt the picture. I'm going to give you a quick sketch. What if we have,
function.
once again, an A and a B? But this time, if you were to connect the two endpoints, it wouldn't roll flat. It wouldn't roll flat. Can we say nothing? No. We can still say something. Actually, might even connect that one against this way. What if it doesn't roll flat? Am I guaranteed a 0? No. If it doesn't roll flat, f of a does not equal f of b, so number 3 is missing. The other two are exactly the same. But if it doesn't roll flat, what I can say is whatever that slope would be, y2 minus y1 over x2 minus x1, or the average slope, or the f of b minus f of a over b minus a, that is going to have a place where the derivative equals that slope instead. Some slope. Even though I'm not guaranteed a flat one, I am guaranteed a parallel one. Even though I'm not guaranteed a flat one, I'm guaranteed a parallel one.
Because the slope is 0 on the,
Yeah.
that's why you can.
So roll flat, if I can connect it with a flat line, there has to be a flat derivative somewhere. But if I connect it with a slanted line, up or down, there's going to have to be a parallel derivative somewhere, a parallel tangent line, which means I just get to guarantee that whatever the rate is, or I should say whatever the rate or slope between two endpoints, the derivative has to equal that slope somewhere. Whether it's 0 or whether it's a number, positive or negative. Whether it's flat or whether it's slanted. So NBT is the general one. NBT is the one that we can always use. Rolls is just sometimes good for us to keep a special eye on. Kiddos, we've taken the bulk of notes for this section because we've covered the two theorems.
You got another one, Tyler?
Tomorrow we have to work on problems.
Oh, yeah.
Tomorrow we have to work on problems. So we have one more thing on this. Homework is not due until the next day. My advice for you tonight might be to work on that FRQ if you have not yet.
Or forever cards.
And then if you have already done the FRQ, update your forever cards. That would be a way of still doing some calc tonight. Sound good? All right, bye, cool kids. I'll see you later. Great job having homework 17 ready to go. Great job. That is. We'll talk more about it tomorrow, but for the other example, the endpoints were the same, so the derivative had to be that somewhere. This one, the endpoints are not the same, so that slope,
due on, all plot ups are due on the 15th.
the derivative,
C's
the
just open
tangent line will
submitting.
have that same slope somewhere.
Our school's doing 15.
We haven't done examples yet.
It's really fast. It takes less than an hour.
But Charlotte, check out this section tonight.